3 now. So chapter 3, we're going to kind of continue with what we were talking about in chapter 2, where we're talking about, looking at distributions and talking about their, what's typical, their variability, different things like that. But more specifically, we want to start honing in on these different kind of distributions that we're going to be talking about. So 3.1 kind of focuses in 3.1 and 3.2 actually focus in on symmetric distributions. Okay, and so we're going to be focusing in on those symmetric distributions and talking about the different statistical analyses, pieces of information that we can gather from this data and use. Okay, and then once we get to 3.3, we'll talk about skewed distributions. So 3.1 and 3.2 are mainly about symmetric distributions. Okay, 3.3, 3.4 kind of get into those skewed distributions and what kind of statistical measurements and pieces of information we can get from the data that helps us deal with summaries and things like that. So symmetrical distributions. When we talk about symmetrical distributions and we look at them, the first thing that we want to talk about is the mean. And yes, this is the mean that you guys know. So it is the arithmetic average of the data. So that means add up all the data and divide by the total number there are. Now, again, in here, I do not want you to do this by hand. I want you to have a calculator or stat crunch to help you, okay? Because sometimes we have a lot of data to deal with. Let the calculators do their jobs. A lot of statistics in here I don't want you to do by hand because sometimes their formulas are extremely long and cumbersome and really, really ugly to do, okay? So in here you see the formula for it. So this is what we call X bar. Whenever you see X bar, that means we're talking about the mean, okay? So this is epsilon X. Epsilon means add up all the X's, or in other words, add up all the data values. That's what this means, okay? It's a summation symbol. So sum all the X's and then divide by the total, okay? When we talk about the mean and symmetric, we think of the mean as the balancing point of the distribution because the mean will closely match the idea of the typical value, your largest bar. Because if it is symmetrical, that means the mean should be in the middle, okay? It should be on that largest bar. So when we deal with symmetrical data, we think of the mean as the balancing point. Okay, half of my data is on one side, half of my data is on the other. Okay, and again, we let StatCrunch, or as today, I will show you how our graphing calculator can help us out with some of this information. Okay, so I'm just bringing up the graphing calculator because I know I'm going to want to use it. All right, so I don't think I have anything else on me. Nope. So when we have symmetrical data, we like to use the mean, okay, as to talk about, typical values, okay, or that balancing point of our data. Okay, within that, we also talk about standard deviation, okay? Standard deviation, it is the measure of how far away the typical observation is from the mean, okay? So this value that they give you is how far away. It's like an average of all the typical observations are from the mean. Okay? So a couple things with standard deviation. This is the giant formula. Again, this is why I don't want you doing this by hand, because if you have a lot of data, let me talk to you about what this formula means real quick. So again, you got epsilon, which means we're going to add. So what you're adding is, the first thing you'd have to do is take every data value and subtract the mean from it. So that means if I have 100 pieces of data, I'm taking each one of those pieces of data and subtracting the mean from it. Okay? And then once you subtract those, you're going to square every answer. Okay? So first you got to subtract every data piece from the mean, then you're going to square that answer, and then you will perform the summation, We'll add it all up. And then once you've got that number, you're going to divide by n minus 1 and take the square root of that answer, and that's what we call S, the standard deviation. Okay? So a couple things. When you're looking at your data, okay, the closer the data values are to the mean, in other words, the more symmetrical your data is, okay, the smaller the standard deviation is going to be. All right, the more symmetrical your data is, the smaller your standard deviation is going to mean. And I'm going to show you what I mean by that here in just a second. Okay. The other piece is know that 2/3 of the data, okay, is between one standard deviation. 2/3 of your data is between one standard deviation. So 66% of your data is between one standard deviation. Again, I'm going to illustrate this here in just a second. All right. So this talks to us about the variability of our data. Okay. So we use the mean to talk about what's typical. We use this standard deviation to talk to us about the variability of our data. And it kind of puts a number with the variability. It's pretty cool. Another thing that you can use to talk about variability, but we don't use it all that much, is what we call the variance. Okay? It is basically the standard deviation squared. So in other words, if you took this standard deviation formula and didn't square root it, that's the variance. Okay? This is that same formula without the giant square root. Just so you know, we prefer the standard deviation over the variance. Reason being, because standard deviation will be in the same units as the mean. Okay? So if the mean is in inches, standard deviation will be in inches. So it's comparing apples to apples. If you were dealing with variance, this would be in inches squared. Okay? So that's why we typically like the standard deviation over the variance, because this makes the units squared, where standard deviation will be in the same unit measure as the mean. Okay? So again, if the mean is measured in, let's say, beats per minute, standard deviation is measured in beats per minute. Variance would be beats per minute squared. Okay? Hope that makes sense. We like standard deviation over the variance. So what you're going to see in your assignment is they're just going to be asking you some questions, okay, about variance and different things like that. So let's go ahead and start talking about how we find all this information and how we can use our StatCrunch and calculator to our advantage. So let's go ahead and bring up StatCrunch. So let me jump in here. Let's open that up. I should have had this open already, but that was my fault. So StatCrunch, opening up the My Lab and Mastering. Okay. Coming out here to StatCrunchy. Just give it a moment. It's thinking about life. There we go. Come on. All right, so opening a new tab, and it's going to open itself to the StatCrunch information. There it goes. There we are. And we're going to want to go to, oops, what is that? Silly StatCrunch. Let's do this again. There we go. Open StatCrunch. All right. So now we're all ready. So we got our calculator. I'm going to show you how to do some of this information on the calculator. I'm also going to show you how StatCrunch will work. It's all the good stuff. Okay. So this first question says, find the mean rounding to the nearest tenth. So make sure that you pay attention to that information. Okay. And then it says interpret the mean in this context. Okay. It says report the mean in a sentence that includes words such as paid vacations. So that's going to be in our interpret piece. Again, a lot of this, you're not actually writing out sentences. It's all multiple choice in there. Okay. And then after that, it wants us to find the standard deviation rounded to the nearest tenth and interpret. And then it says which number of days is furthest from the mean and therefore contributes most to the standard deviation. Okay. So we'll talk about that one as well too. All right. So let's go ahead. Let's find the mean. Okay. So we need to add all these up and then divide by the total number there are. Now, this is simple. You can go to your calculator and add these up. There's not a lot of data here. There's only 6 values. But let's go ahead and let's talk about how we can use the calculator to help us out. So we're going to take these values right here, and we're going to put them in our calculator. We don't really need the states because that doesn't matter. Because, again, the mean is all about the average of all this. So if we go to our calculator, in order to put data values in, since we're in statistics, we're going to come right here to stat. So click on stat. Click on the edit, because right here we want to edit. We want to put values in our list. And in here, in list 1, this is where we're going to put our information. If list 1 had some values in it, just say, I'm just putting some values. Let's say, oh, my list 1 has these in here. You can do a couple things. You can come in here and delete it out if you want. Or you can scroll up to the top and hit clear and then hit enter. And now it cleared everything out. Okay, either way. So we want to put those values in here. So we got 0, 20, 20, 30. So 0, 20, 20, and 30. And then we have 24, 10. 24 and 10. Okay. So now we want to find the mean for this. Here's what's really cool. Go back into stat. Okay. And you're going to scroll right over here to calculate. All right. Scroll over to calculate, and you're going to run one variable statistics. We want this very, very first guy right here. And all you're going to do is hit enter, and you can either scroll down here to calculate, or you could hit enter 3 times, and now you've got some information. Oh, look, X bar. There's the mean. Hey, right here, you've seen this. Epsilon X, in other words, summation of X. So if I added up all those numbers, here's what they all added up to. Okay? Now, a couple other things, just to show you some things right here. This is if we squared all those entries and then added them up. So this is this we don't really worry about. Right here, this SX, this is our standard deviation. Okay? This right here is our standard deviation. We'll talk about this guy later on. This is also another standard deviation, but right now, this is the standard deviation we want. Okay? So SX. S for standard deviation. X bar, there's your mean. Some other cool things, if you didn't know, right in here. Here is N, the total number of values. So if we actually took 104 divided by 6, that gives us the 17.33333. Okay. The minimum value was X, so that's our smallest data entry. Tells you things about quartiles, the median, and quartile 3. This is all stuff pertaining to section 3.3. And then there's our max value, which was 30. Okay? So lots of cool information in here that our calculator gives us. And again, our question said, what's the mean rounded to the nearest tenth? Okay? So to the nearest tenth, that means that we have a mean of 17.3 paid vacation days. Okay? 17.3 paid vacation days. So if I go back to that, what does this mean? So here is the sentence that I would write. Okay? For these 6 countries we looked at for paid vacation required by law, the average was 17.3 paid vacation days. See, there we go. And I use such words as paid vacation days. Okay. And it's important to say that it's an average because that's what the mean is. Okay. It's an average of all these. Okay. So on average, between these 6 countries, individuals got 17.3 paid vacation days. Standard deviation. Okay. So it says find the standard deviation, round to the nearest 10th. So our standard deviation is 10.7 paid vacation days. Okay. So what that means is that on average, these numbers vary from that mean of 17.3 by 10.7 vacation days. Okay. So they vary from this on average about 10.7 paid vacation days. So if we kind of go back and talk about this, remember how I said 2/3 of the data is between one standard deviation? So if I went back in here and I went out to my calculator and I said 17.3 plus 10.7, so this is our mean. This is what we consider one standard deviation above the mean. And then if I take 17.3 minus 10.7, so 2/3 of my data, okay, 66% of my data should be between 28 vacation days and 6.6 vacation days. So if I go back and look at this, if I go back and look at my information, this is between the 28 and the 6.6. This is between the 28 and the 6.6. This is between the 28 and the 6.6. And this is between the 28 and the 6.6. That's 4 out of 6. That's 2/3. So 2/3 of my data up here was between one standard deviation. That's what this meant right here. Okay? Because this number right here represents one standard deviation above the mean because we added. This represents one standard deviation below the mean. Okay? So on average, when we were talking about this, going back to our problem, so we know that the standard deviation is 10.7. What does that mean? On average, these 6 countries vary 10.7 paid vacation days from the mean. Okay? That's what they mean. That's what they want. That's what they're looking for. Nothing crazy. They just wanted a small little answer like that. All right? Then down at the bottom, which number of days is furthest from the mean? Okay? So if you look up here, the mean was 17.3. So the number of days that is furthest from the mean would be the United States. Okay? Furthest, remember, can mean above or below it. The United States is 17.3 away from the mean. Okay? This guy right here, if you take 30 minus 17.3, it's only a distance of 12.7 away. Okay? So in this question, it says, which number of days is furthest away from the mean? The United States. Okay? That's the one that is contributing most to the standard deviation that makes it so high, because this one is the furthest away. Okay? Hope that makes sense to you. Yeah, but that's all you're doing. Again, all these questions down here where it says interpret, things like that. This is all going to be multiple choice. Okay. All right. Let's take out another one. So right here, it says compute the mean and compute. Oh, I almost forgot. We didn't do this in StatCrunch. Let's do that real quick. Let's talk about how StatCrunch gives us information. So you saw how the calculator can help you. Let's talk StatCrunch. So in StatCrunch, again, all we got to do is put those values. So 0, 20, 20, 30, 24, and 10. I believe those were our values. Let me double check. 0, 20, 20, 30, 24, 10. Good. Okay. So up in here, now we're going to go into stat. Okay. And we want to run summary stats. So you're going to go into columns because we're not worried about a row. We want columns. And all you're going to do is variable 1. I could have named this if I wanted to. You don't have to. But we just want to run variable 1. So compute. And now you got a lot of information. So let's talk about this. What do you see here? All right. So here you can see the name of the column. So if I wanted to name this paid, what did they call this? Paid vacation days. If I really wanted to, I could have come in here and called this paid vacation days. I really wanted to name it. And then I go back into my options and I can edit it again. See paid vacation days and compute. Okay, it doesn't really matter as long as you know what that column is about. So right here, here's the n that represents the total. You can see the mean. Okay, so here's the mean. Here is the actual variance. Okay, so this is that number before they took the square root and got you the standard deviation. So there's that standard deviation we talked about, the 10.7. Don't worry about standard error. That'll come in later on. Then you can see the median, the range, the minimum, the maximum, quartile 1, quartile 3. So pretty much all the same information that we had from the graphing calculator, other than this one is a new one and this one is a new one, and the variance is kind of new. This is why I like the StatCrunch a little bit better, because it's actually going to provide us the information that we really do need, over the calculator. But again, you do you, boo. You do you. Whatever you understand the best, use it. Okay? But again, StatCrunch is available in the homework, quizzes, and tests. Your calculator is available during homework, quizzes, and tests. So again, there's that mean, there's that standard deviation that we were after. And there it is. That's StatCrunch. So again, all you do is you put your data right here, and all you're going to want to run is stat, and you want it to do a summary stats for the column. Okay? And there you go. All right. So let's jump into that next one. Let me go ahead and delete this information out. Yep, delete it all. And we'll clear this stuff out. And clear column. There we go. All right, now we're back to normal. So let's jump over into this one. So in the next one, it says that college student Jacqueline Loya asked a group of 50 employed students how many times they went out to eat in the last week. Half of the students had full-time jobs, and the other half had paid or part-time jobs. So again, down here it says compare the means and compare the standard deviation. So that means you need to find the mean and the standard deviation for full-time and the mean and the standard deviation for part-time. This is where StatCrunch would be a little bit better because you can actually bring both of those pieces of information up on the screen. If you do this in the calculator, you're only going to be able to see one piece of information at a time when you deal with it. Okay? So I'm going to use StatCrunch on this when I go through it with you. But again, you can use either one. Just know that when you do the calculator one, you'll need to write down some information as you go. Okay? So go ahead and pause the video. Give this one a shot. All right. So again, I'm going to jump into StatCrunch for this. Okay? And we're going to start talking about finding the mean and the median and all that good stuff. Okay? So StatCrunch. Again, this is going to be the longest part. I think it's going to be important to, oops, accidentally click some stuff, to name this. So let's say full-time, and part-time. Okay? So full-time, let's see if I can just squeeze this over here so I can see those numbers at the, oh, of course you're not going to. So let's do this. We'll shrink this down some. That way I don't have to keep flipping back and forth. All right, so full-time jobs is 5, 3, 4, 4, 4, 2, 1, 5, 6, 5, 6, 3, 3, 2, 4, 5, 2, 3, 7, 5, 5, 1, 4, 6, 7. Let's get this information out of the way. So we had 25 entries, so we should have 25 entries over here because it said half and half. So 1, 1, 5, 1, 4, 2, 2, 3, 3, 2, 3, 2, 4, 2, 1, 2, 3, 2, 2, 3, 2, 1, 3, 3, 2, 4, 2, 1. There we go. Perfect. All right. So kind of maximizing everything back out again. So let's go ahead and let's find some information. So we need to summary stat column. So I need to do full-time. There we go. And then I need a summary stat column. I need part-time. All right. So the mean for full-time is 4.08. The mean for part-time is 2.36. So again, it wants us to compare. So in this, full-time employees on average eat out more than the part-time. Full-time employees on average eat out more than the part-time. Okay, you can see that. Standard deviation, this is 1.7. This one down here is 1.1. So what this means for us is that the full-time, because this number is a little bit larger than that, that means the full-time has a little bit more variation in their numbers. Okay? The larger your standard deviation, the larger the variance, the more spread out it is. Okay? So when you look at these two, this one has a larger standard deviation than the part-time. So that means the full-time, they ate out, they're eating out varied a lot more than the part-time. Okay? Because these had a smaller standard deviation. So what that means that if we actually looked at a graph of this, the part-time data would be more symmetrical than the full-time data. Okay, so if I graph this, let's actually take a look at the graph real quick so I can show you that because I said that I would show you that a couple minutes ago. So let's say full-time compute. So there's the full-time. And then let's go and let's get the part-time. Histogram part-time compute. Okay, so let's go in and let's fix these options. Start with 0 and bend width of 1. Let it fix that. There we go. So you can see how it's a little bit more symmetrical here. Okay, and you can see a lot more variance here because it goes all the way out to 8. This one goes all the way out to 6. So this data is closer together. Okay, the closer your data is, the smaller the variance. That's what I was talking about back here in this problem that was right here, or in standard deviation. How I said the closer your data values are to the mean, the smaller the standard deviation. Okay, so when we look back at this information, you can see that these numbers are closer to that mean value which is right here. Okay. We can verify that mean value. See, the mean value was 2.36, and that's definitely our largest tower here. Okay. Over here, our mean value was 4.8. So I know this one is 5. 5 is our largest, but the balancing point is actually, or 4.08 is right in here. Okay. So it's pretty close to being the largest tower. Just so you know, it was off by a frequency of 1. It's still pretty close. But this, notice that there's a lot of variation in here. There's a lot more data that's spread out. Okay, so I just want to illustrate that point. The smaller the standard deviation, the more compact the data will be. The larger the standard deviation, the more spread out it will be. Okay, because you'll have a question kind of like that. So let's go ahead, let's get rid of this information. Okay. Delete the column or clear the column, all the same. And we can actually just get rid of all this information because we don't need it anymore. So going back to our problem, so we found the two means, we found the standard deviations, and we talked about it. Okay, so in here, the full-time people on average ate 4 meals a week, where the part-time people ate 2 meals out a week. Okay, so full-time ate out during the week more than what the part-time did. Standard deviation, there was more variance with the full-time because they had a larger standard deviation than the part-time. Okay. So there we go. All right. So, hey, look at this. Something kind of similar to what maybe I was talking about a moment ago. It says, look at the two histograms created from 2009. Real estate data taken from Ventura County Star, and decide whether you think the standard deviation of the homes in Agora, California, is larger or smaller than the standard deviation of the homes in Westlake, California. Okay, so Agora, Westlake. Which one has the larger or the smaller standard deviation, and explain. Go. Okay, so when you look at this, if you look at this data, okay, A is the one that will have the smaller deviation because all that information is right here from 600 to basically about 100 is right here around this 400. This one is it's closer together. It's more compact. Okay, so A has the smaller, which means that B would have the larger. This guy would be the larger one. Because again, the data is more spread out from 200 all the way up to 800. Okay. And there's a large gap here. It's not close together. I mean, you got a little bit of a gap here, but not as large of a gap right there. So there's more variance over here. And also, if you notice, it's not quite symmetrical either. I mean, there's a lot in the 200s right here, but, you know, I mean, it really ranges in the upper half. So B is the one that will have the larger standard deviation because there's a little bit more variance. It's not as close together as what this data is. Again, the closer your data is, the smaller the standard deviation. The further your data is spread out, the larger the standard deviation. Okay? And I think this is the last one. Let me check. Yeah. So this one, it says the mean birth length for U.S. children born in full term after 40 weeks is 52.2 centimeters. So that's about 20.6 inches. Okay. So what you now know is you know that X bar is 52.2 centimeters. Okay. It says, suppose the standard deviation is 2.5 centimeters, and the distributions are unimodal and symmetric. Oh, that's also important for your symmetric data because we are dealing with symmetric. We want it to be unimodal, okay, unimodal. We don't want bimodal. We want unimodal for this, okay? Symmetric and unimodal is really good for standard deviation and means. All right, so they told us that our S then up here is 2.5 centimeters. Okay, so it says, what is the range of birth lengths of US born children from 1 standard deviation below to 1 standard deviation above? This is what I showed you when we talked about those paid vacation days. If I want to do 1 standard deviation above, all I'm going to do is take 52.2 and add 1 standard deviation of 2.5 to it. So if I take 52.2 plus 2.5, 1 standard deviation above is 54.7 centimeters. So that's the top of 1 standard deviation. If I want 1 standard deviation below, I'll take the 52.2 and subtract 2.5. And so just come up here. I'm just going to grab that answer right there and come over here and change that to subtraction. So 49.7. So what we now know is that between 49.7 centimeters and 54.7 centimeters, that's 66% of my data. About 2/3 of my data is between these two values. Okay? So there's our first piece that they wanted. What's the range? And it's from 49.7 centimeters to 54.7 centimeters. Part B says, is a birth length of 54 centimeters more than 1 standard deviation above the mean? Okay, so in other words, is this number right here bigger than my top value? And no, it is not. So is this more than 1 standard deviation? No. That's what they're asking you on this question. Okay, in other words, kind of like what they're trying to get at with part B is they want to know, is this unusual? Which that we will talk about in section 3.2 about unusual data entries. But for right now, all they want you to do is understand mean and standard deviation for symmetric unimodal data. So now you can jump into chapter 3 assignment, and you should be able to do questions 1 through 13. That deals with section 3.1 only. And until next time, have fun, my little friends. Oops, I need my little come back. There it is.